Hey everybody, welcome to our quick video lecture on some of the advanced statistical tests that we're going to cover for this semester. Let's get started. So I'm not going to read or have as my background the first couple of slides because I want to talk to you for a second. Let's think about the purpose of this course, all right? And you can read the learning objectives. What I want you to notice is what we're trying to do with this course is improve what I would call your statistical literacy. And what that means in more of a functional definition is you're going to read a lot of research, right? You read a lot of research as an undergrad. If you go on to graduate school, you're going to read even more research. Even if you don't go to graduate school, you will read research. It may be summarized in a news article more than the direct article, but still. We consume research and research findings on a daily basis. But not everybody understands what they're reading, right? Like, let's talk about you as an undergraduate student, and you're presented with the PDF of a research article. Chances are you read the abstract because that's a nice summary, right? You may read a little bit of the introduction, which is like a literature review. And then probably you're skipping all the way to the discussion because the discussion is where they kind of discuss the results a little bit more in maybe language you understand, right? Some of you may not even be reading beyond the abstract. What this course is hoping to help you with, and especially this course and the methods course, is to help you be able to understand the methods section and a little bit of the results section. So those are two very important sections of the article, and not just because every section is important, but like for real. The method section is where the authors are going to tell you what they did, but that's also where we really start to critique research. You can really critique a research article by its sampling. Is it a diverse sample? Is someone like you in the sample? Are they overreaching, right? And are they trying to apply their results to people who aren't represented in this sample? How did they measure their variables? How did they manipulate them? Does that make sense? Is that reliable? Is it valid? And then we have the results section. And what we're hoping, again, is to improve your statistical literacy so that you can understand more result sections than you could at the beginning. As you've seen from a lot of our APA assignments, there's kind of a formula way that we write results. Now, that being said, there is no one class that could prepare you for every possible statistical design you might ever read. First of all of the statistics that we require for this degree are quantitative. There's a whole other branch of research called qualitative. And so there's a whole other branch of research that we haven't even covered. And even then, within quantitative, there are plenty of other tests that we haven't covered, right? So the purpose here of the whole course is to improve your statistical literacy, not only so that you do better in your future psych classes here at Kennesaw, not only so that you do better as an undergraduate student, but so that you have those skills to transfer to other parts of your life, whether or not those parts of your life include graduate school or those parts of your life involve the amount of research that we are exposed to every day. So like I said, we do want to make it so that you can understand more of what you're reading. And that's a lot of what this last module is about exposing you to some of the other advanced statistical tests that you might read in psychological articles. Is that going to be every statistical test? No. There's plenty more even beyond the ones that we're exposing you to, right? But for this PowerPoint, the ones that I'm about to cover, you're not going to have to hand calculate them. You're not going to have to run them through SPSS. You're not even going to have to interpret their SPSS output. All you need to be able to do for these advanced ones is to be able to tell them apart from some of the other tests that we've covered. And we're going to talk about how you do that in a second. Now, I do hope you notice that this slide here shows just how much work that y'all have done this semester. These are all of the tests we have covered up until this point. You've done a tremendous amount of work. The next two slides do have some charts to help you keep up with some of the tests, and I would encourage you to use these and refer to them, especially when you do our last homework assignment that's in our final module before the exam. But let's get to what are these advanced tests. Our first one is called a MANOVA, and that's M plus a nova, so MANOVA. And it stands for a multiple ANOVA. What is the point of this one? Well, I hope you notice that everything before this moment, there's only been one outcome variable. one dependent variable. But some things might affect multiple outcomes. What do we do about that? That's where the MANOVA steps in. Now there's two kinds. There's a one-way MANOVA and there's a two-way or factorial MANOVA. And you tell them apart exactly the same way you tell a one-way ANOVA from a factorial ANOVA. Okay? Let's use some examples. Again, you can read through this slide and you can read the example on the slide, but I want to do a couple of extra examples here in our video lecture just to make sure that you understand it. So let's try an example. Let's say I was interested in our dependent variable or our outcome variable being stress. I tend to pick on stress a lot in my examples. Well, what are some of the variables that we know are related to stress, particularly things that might improve stress? When I had some psychology students generate some ideas about this in one of my synchronous or hybrid classes, one of the ones they came up with was exercise. And yes, we do know that exercise does improve someone's perception of their stress levels. Let's say I decide that I'm going to sample a group of people and I'm going to assign them to one of two groups. Group 1 is going to do just cardio exercise and group 2 is going to do strength-based. What kind of statistical test is this? Well, if there are two groups and nobody from group 1 can also be in group 2 and nobody in group 2 can also be in group 1, there's just two groups and one outcome, well, that's an independent samples t-test. If we add a third group and we have that third group just be walking, now that we've added a third group, we've changed what statistical test this is. If there's just one variable that has three levels or three groups, that would be a one-way ANOVA. So what's on the screen right now is a one-way ANOVA. You've got one variable, exercise, that has three levels, which makes up the three groups, and we're just measuring one outcome, and that's stress. So as it stands now, this would be a one-way ANOVA. How do we make it a MANOVA? To make it a MANOVA, we need to have another outcome that we might be interested in. And again, when I had some synchronous students or some hybrid students, one of the ones they suggested was performance. And depending on what kind of psychologist you are, this could be all kinds of performance. It could be, if you're an IO person, maybe employee performance, or if you were more interested in SOTL, which is the Scholarship of Teaching and Learning, maybe it's student performance, and that would be something like grades or your performance on a test or something like that. The key here is that we now have two outcomes. To summarize, we have one factor, one cause variable, independent variable, and that's exercise. And we know it's not a t-test because we have three levels of it, right? We have group 1, group 2, and group 3 of this one variable exercise. But instead of just having one outcome, we now have two potential outcomes we're looking at. That would make this a one-way MANOVA. What about factorial? If we wanted to make this into a factorial ANOVA, we just need another factor. So we would ask ourselves, what are some other variables that are known to improve stress? Well, there's lots of things. I could do maybe a coping skills workshop where we teach some people some specific methods of coping and some people don't get the workshop. But honestly, it could be anything. We have lots of things that are associated. Maybe I want to throw yoga in there. Maybe I want to throw in coloring, time in nature, time with others. There's lots of things I could do to add another factor here that I could manipulate. If I have factor A with 3 levels and I have factor B with 2 levels and just one outcome, again, one DV, that as stress, this would be a factorial ANOVA. Specifically, this would be a 3x2 factorial ANOVA, because remember, you refer to factorial ANOVAs by how many levels they have of A and how many levels they have of B. A comes first in the alphabet. So there's 3 levels of A and there's 2 levels of B. This is a 3x2 factorial ANOVA. But how do we make it a MANOVA? We make it a MANOVA the same way we made the other one a MANOVA, in that we add another outcome. Again, we could use performance like we did in the other example, but maybe I want to change my outcome variable to something like life satisfaction. So again, I now have one factor, factor A, a second factor, factor B, and 2 outcomes. So this would be a 2-way or factorial MANOVA. The real key here is that you tell an ANOVA, a one-way ANOVA from a 2-way ANOVA or factorial ANOVA, the same way you tell apart a one-way MANOVA and a 2-way or factorial MANOVA. And you tell ANOVAs apart from MANOVAs by how many outcomes they have. In your notes, you can also separate them this way. One factor with at least 3 levels and 1 DV outcome, or 2 factors with 1 DV outcome, these are both ANOVAs. Whereas the ones below the line both have 2 or more DVs or outcomes. These are MANOVAs. But we also can tell them apart in that the first 2 both have 1 factor. That makes them one-ways. And the second one in each have 2 factors or more, and that makes them factorial, or 2-way. So again, you can go back to the PowerPoint and review the 2 slides that cover one-way MANOVAs and 2-way MANOVAs, but hopefully that helped clarify everything and give you another example. Let's move on to the next one. That would be ANCOVAs. So it's the word ANOVA, but it has a C in it. What does the C stand for? The C stands for covariates. What is a covariate? A covariate are characteristics excluding what you're actually doing, what you're manipulating, your treatment, that is related to the participants in the experiment. It's usually participant factors, some kind of difference between people, or some other kind of variable that we know is related. Notice the big question here on the slide is, do differences still exist if we control for the covariate? I have an example here on the slide, and I'm going to do another example in a second. But I find that this is the one that students struggle with, and it's because this is the one that actually takes a depth of knowledge in a specific topic. I, as a researcher, because the step 1 of all research is to read, have read a lot about the topics I'm interested in. So I know that some variables are related to each other because of all the research I've read. What a covariate is like that. Let's say I'm interested in one variable and how that variable affects a particular outcome. But because I've read everything, I know that that outcome is also related to a lot of other variables. But I'm not actually going to manipulate them. But I might want to measure them, and I might want to take them into account when I do my statistical tests to make sure that the one I am manipulating still actually is affecting the outcome. So like I said, you can read the one that's on the example that's about reading comprehension. I'm going to do one that's a little bit more specific to my field. So my field, or my specialty, is human sexuality. Let's say the outcome that I'm interested in is how often people use barrier methods or condoms when they have sexual intercourse or other sexual behaviors. So my DV outcome is going to be the condom or barrier use frequency that someone reports to me. Because I've read a lot about human sexuality, I know there's lots of variables that affect whether or not someone chooses to use a barrier method or condom when they have sexual intercourse or other kinds of sexual behaviors. One of those is their attitudes towards condoms. Think about that for a second. If your attitudes are positive, you're probably more likely to use them. And if your attitudes are negative, you're probably not, right? Makes sense. So what is something that I can do to affect people's condom attitudes? Maybe group 1 watches a short PSA on condoms or barrier methods. And maybe group 2 is given a pamphlet, like the kind of thing you would be given in a doctor's office. I recruit a sample. I have the participants randomly assigned to either group 1 or group 2. Group 1 does what they do. Group 2 does what they do. I let them return to their lives for maybe a month or so, and then I ask them how likely they are or how often they use condoms or other kinds of barrier methods. As it stands right now, we have group 1 and group 2 that represent a single independent variable, and that single independent variable is being examined for its effect on a single outcome. So this is, again, an independent samples t-test. How do we make it an ANOVA? Well, we add another group. Maybe group 3 actually attends some kind of brief sexual education workshop. Now I still have one variable that has 3 levels on one outcome. This would be a one-way ANOVA. How do I make it an ANCOVA? Well, I have to add the C, and that's a covariate. So again, as a researcher, as someone who's, this is my specialty, I've read a lot about what other kinds of variables affect whether or not someone uses a barrier method when they have sexual relations with others. In addition to your attitudes on condoms, a huge one is your sexual communication skills. So this would be things like advocating for condom use, or if your partner said, no, I don't really want to do that, how would you continue the conversation? What kinds of things do you say to your partner? How do you talk about sex? So what I would do in this situation is I would use a published measure that measures people's own assessment of their sexual communication skills. And then I would take that into account. And I keep using air quotes because that's the most common phrase that you'll hear when someone is talking about an ANCOVA. I'm just going to measure that. And then I'm going to plug that into the statistics that I do. And I'm going to hold that to see whether or not, once you look at people's differences around their sexual communication skills, do my different groups that are supposed to be affecting condom attitudes, do they still work? Do they still affect whether or not someone's using these barrier methods? Again, the real key here is that ANCOVAs tend to be hard for undergrads to understand because you don't know about the covariates. You might understand the definition of the word covariate, but you don't really understand what covariates are because, again, you don't have a depth of knowledge in a specific topic. But you probably do. You might not have one about the kinds of examples that we use in this class, but you probably have a depth of knowledge about something in your world, right? And so for that, you probably could understand them if you could just translate these examples into the things you do have depths of knowledge about. The real key here is to listen for the phrase takes into account or covariate. I encourage you to also read the example that's on the slide. So here's our last one, hierarchical regression. Now, you've already done one kind of regression, and that's a simple regression. And to remind you, when we hear the word relationship, you should think correlationship, and that the correlation tells us that two variables are related to each other, right? Either in sync, right? As one goes up, the other one goes up, or in an inverse relationship, as one goes up, the other one goes down, right? Once we use a correlation, we can also then do a regression. The key word with regression is predict, because the regression is going to allow us to take that relationship and predict along it, right? We can predict how future participants or future people might behave on a variable because of this established relationship. So again, correlation, relationship, regression, predict. But the regressions you've already covered are simple. They're only two variables, just like a correlation. But we do have a more advanced form of regression. In fact, there's lots of kinds of regression. But the only one I want you to know for this class is a hierarchical regression. What's the difference between a simple regression and a hierarchical regression? Add more variables. So as you see here on the slide, we're running multiple regressions to see how much variance in the dependent variable is accounted for when you combine other causes or other variables. Let's say that we know X and Y are related. We can predict Y from X. That's a simple regression. But what about C and D? How much of Y can you predict if we combine X, C, and D? So I have an example here, but I'm going to work through it with you in the Word document first. Okay, so just a reminder, regression is to predict. Let's say the variable I'm interested in predicting is how much time someone spends online gaming, playing online video games. Perhaps I want to first look at variable 1, how much loneliness they report. So if I'm just going to use loneliness as a variable to predict time spent gaming, that's only 2 variables. It's a simple regression. You've already covered that. And the only reason why I would look to see if I can predict that is because I've probably already run a correlation to show that they're related, which they are if you read the research. But surely loneliness is not the only variable that predicts how much time someone spends online gaming. What are some other options? Let's say I'm going to look at all 5 of these variables. I'm going to look at loneliness, stress, depression, addiction, and immersion. By the way, this is very similar to my dissertation. So the reason why I picked these variables is because I wrote a dissertation on these variables and time spent online and online video gaming, particularly people who play online MMORPGs, which is massively multiplayer online role-playing games, things like World of Warcraft. So there are articles that show that all of these variables are related to the time that you spend online gaming. And I'm interested in which of these can I actually predict well with, okay? So we're not talking about a correlation because a correlation is only 2 variables, and I now have way more than that. I'm also no longer talking about a correlation because I'm talking about predicting a variable. So because I've used the keyword predict, I know it's a type of regression. Well, you've only learned simple and hierarchical, and a simple would require, again, 2 variables. I have too many. So again, I know that this is a hierarchical regression. But let's give you a real example. So let's say I scatter a lot of information, and what I find is that depression is not a good predictor at all. And instead, these 4 are predictors: loneliness, stress, addiction, and immersion. Well, the reason why this is called a hierarchical regression is because it is going to help us place these variables in order from the strongest predictors to ones that are less strong. And what we might find maybe is that stress is the strongest predictor, but these other 3 are also good predictors, and that one I deleted was not a good predictor at all. So it's called a hierarchical regression because you're putting the variables you can use to predict in a hierarchy of which ones are the best or strongest predictors. And that's a hierarchical regression. So those are the additional tests that I want you to know. Again, conceptually, you're not going to have to do math on these, right? You've got 2 kinds of MANOVAs, a hierarchical regression and an ANCOVA. So you're going to add those 4. And again, I want you to notice that there are 2 slides in here that are helping you to summarize the tests that we have covered this semester. These new 4 just have to be added to this in your notes. For our last homework, you're going to read little brief study descriptions and try to select the right test. Again, because that's a cumulative skill for this class. And there's going to be a part of that on our last exam. So review this, let me know what questions you have, and I'll see you online.